consider myself an aquaculture scientist, and so I'm going to give you just a really global tour. You expect me to sort of sing the praises of aquaculture, but I can tell you that it's been a long road. The field is even larger than agriculture. So can you imagine somebody standing in front of you and saying you're an agriculture scientist, knowing how diverse agriculture is? But I'm going to give you an idea of how much further this field needs to go. A person like me has been, a pioneer. In one of the pioneers of probably only 200 or 300 people when I started in the 70s in this field. It was more of an art than a science. And most of the scientific institutions that I was in, they actually denigrated aquaculture. They didn't even want to say the word. Indeed, I've given talks in places in the world, one of them I'll never forget, in British Columbia, where I landed and got a taxi, and the person said, what are you giving a talk on? And I said, aquaculture at the University of British Columbia. And he said, are you for it or are you against it? And I had a bit of time to kind of process that, because are you for agriculture or are you against it? I mean, really. So it really is not the blue revolution, which gets a lot of press these days. It's really still 40 to 50 years into it, and thousands of years before that. I'm going to go way back with you. It's still real new, and it needs to go a long way before it's really recognized as an important part of our diet, particularly in the West, not in the East. Okay, so science just recently, FAO said that by 2050 we're going to have 10 million people. Now science just came out and said, look, we're not counting a lot of those people in the suburbs of Jakarta or in Nairobi, and they're saying now 12 billion, okay? 70% of the world is Mother Ocean, right? But we only derive only 1 to 2% of all human foods from the ocean, okay? So if we want to continue to have amazing ecosystems like the Serengeti, like the Amazon, like the Pampas in Chile and Australia and Argentina, like the Great Taigas, if we want our national parks for our children and grandchildren, agriculture will destroy the planet. The rest of the most important ecosystems and nature reserves on the planet, agriculture will destroy to feed 12 billion people. Okay? There will be none of those ecosystems left. So we have a moral and ethical and production imperative, science imperative, to feed this planet more from the ocean, not from the land sphere. It's got to happen. Now the question is, can we do it sustainably without destroying the ocean? Okay, so you're going to date The Economist of this, so it says Schwarzenegger to run. Okay, sort of date that a little bit, okay? But this was the vision of The Economist. And is this the vision of the future of aquaculture? Sort of corn that has basically sort of taken over almost all of the natal ecosystems of the U.S. Midwest, from riverbank to riverbank. And I understand that in the Midwest also, because the corn prices, because of ethanol, now they're sort of even destroying some of the conservation areas along the riparian areas of the rivers. Is this the future of aquaculture? Salmon stacked up like corn in a wheat field or a cornfield as far as the eye can see. Is that what the future of aquaculture is? And so I got together with a bunch of colleagues who were really put off by the movement towards industrial farming and large multinational farming for aquaculture, because we had spent time, as you heard from my bio, I spent almost 10 years of my life living in Indonesia and in China, and then I moved to Africa and lived in sub-Saharan Africa. And we knew that there was not only a history of aquaculture that went back 4,000 years, but there was a her story. It was gender issues, it was community issues, it was social ecology, not only natural ecology. And we needed a new type of scholarship. So we got together and we talked about, it's not the blue revolution. even though there's been blue revolutions throughout human history, and I'm going to tell you about those because they're really exciting, because I've got probably only 10 colleagues worldwide, 10, who study the archaeology and anthropology of aquaculture. How do aquatic food systems arrive in societies over historical time? It's virtually unstudied. Whereas some countries, over 70% of their total animal protein comes from aquaculture or from the ocean. It doesn't come from the terrestrial sphere. So it's a really neglected area of human evolution. So we got together, we put this book together, and we put Makoa, the mullet runner, on the front cover. Makoa, this is a beautiful Dietrich Ferrez. If ever you have been to the Big Island of Hawaii, does all these beautiful woodcuts at the Volcano House. And Makoa was a mullet runner when Captain Cook arrived in Hawaii. Okay, when he sailed into Waikiki, there was 360 integrated, unpack slow with you, integrated mariculture, sea farming systems, integrated all the way through from the sea farms all the way up through the tops of the mountaintops. Integrated watersheds. Why? For food. Because one of my Hawaiian friends said in his interminable pidgin, he said, "Hey, brah, hey, haole." There was just as many Hawaiians when Captain Cook arrived back then as there is today. So you're going to find there's a big controversy among anthropologists today in the world saying that in ancient societies were very densely populated. Hawaii was very densely populated when Captain Cook arrived. So densely populated that there was all of these kapus, these regulations on capture fisheries. Very stringent. Can't harvest this time of year. So as soon as that starts to happen, you start evolving farming systems. People start developing an intuitive indigenous wisdom of growing food in water. They develop aquaculture. So when you go on, my community then, I don't like big Blackwell publishing stuff anymore because the book then became too expensive for anybody to buy it. So now we put everything for free. So go on the web and you can, anything that we do, our community, you go on the web and you can get anything. You can get anything and everything for free. Open access knowledge for the planet. Thank you. So a little bit about the evolution of the Blue Revolution. How about the humans standing in front of you today? It's been quite a journey. So you always see these pictures, aquaculture growing and growing and growing, but where is it growing? That's really an important story. And how about in 1972? 1972 was the first time I got into aquaculture as an undergrad, and I really studied intensely. And this was the book we used. It was this thick, and it was called Aquaculture. Can you imagine it today? The aquaculture fills entire libraries these days, just on nutrition, just on aquaculture nutrition, feeds, okay? And that was the one book, and that was 1972. So then in 1982, I got my PhD in 1984 from the University of Hawaii in Manoa, okay, where I studied shrimp farming. And now everybody eats shrimp, and a lot of the shrimp that you eat, unfortunately, are farmed and not maybe the best systems today, okay? But we, in 1982 and 1984, we didn't know how to put mommy and daddy together to produce babies. Indeed, when we found how to put mommy and daddy to produce babies in a hatchery, then they produce babies, and the next day we come into the hatchery, no, I'll be dead. And so it was an art. It wasn't a science. We had to, there was probably only 50 people in the entire world in 1982 learning how to do shrimp aquaculture. And now it's millions and millions of metric tons, and it's all over the world. But how about farmed salmon? Many of you have your strong opinions about farmed salmon. It weighs heavily on the future of aquaculture. It weighs heavily. Whereas, here I'm doing shellfish and seaweed aquaculture in Maine in a communities all up and down our beautiful 3,500 miles of coast. But people will ask me, aquaculture, are you for it or are you against it? Because they're thinking I don't want those salmon pens in my backyard. I don't want to look at that. I am opposed to salmon. And here I'm talking about shellfish. But the first farm salmon in the world appeared 2 years before my PhD. I remember those conferences that I went to where we would share, oh, all my shrimp died today, and all the people would say, oh, all my salmon died. So just remember that. The entire development of industrial salmon farming, shrimp farming, tilapia farming, catfish farming is in the lifespan of this energetic person standing in front of you today. Just remember that. It's really not a revolution in this form, in the industrial form. The industrial form of aquaculture has only arisen since the 1970s. But that's not the whole story. The story starts in 4,000 years ago. But it goes through 4,000 years of evolution of people who are very densely populated in countries that are seafood-eating countries. America is not a seafood-eating country. Americans eat 130 pounds per capita of beef per year, or meats. We eat 13 to 14 pounds of seafood per year. In Asia, it's completely the opposite. They eat 130 to 150 pounds per capita of seafood per year and only about 10 pounds per capita of meat per year. Times that by the billions we know that are there in Asia, and guess what? Where is aquaculture the most predominant in the world today? Asia. Over 80 to 90% of all global aquaculture production today is in Asia. Everywhere else, aquaculture is minor, literally insignificant in the United States as part of our food sources. Yes, you may eat aquacultured mussels. Oftentimes, we've got a great mussel industry in the state of Maine, and all of our mussels that come from PEI Canada. Okay, so Americans get 90% of their seafood by imports. The U.S. trade deficit in seafood is only superseded by oil and cars. Oil is number 1, automobiles is number 2, number 3 is seafood. So we import everything we eat and we export everything we produce. So it is the world's most insane food. And so we, as a community, we talk about trying to educate people about what they're putting in their mouth. They're more concerned about their spinach and broccoli, where that's coming from, and hardly pay any attention to the kind of seafoods that they're eating. But let's rewind a little bit. So it's Asia. So every time I want you to hear a press release that the world is eating half of its seafood from aquaculture, not true. Because you probably thought that was coming from your local jurisdiction or the United States. The world is only eating less than 10% of its seafood from aquaculture. In Asia, they're eating more than 90% of their seafood from aquaculture because they have so destroyed their fishery systems. Now, there's a global need to recover and restore fisheries. But Asia is, a lot of those environments are in desperate shape, and they've moved to aquaculture. The other thing is, how many people, just sort of soar up and raise your hand, how many people ate carp in the last year? How many people ate carp? 1, 2, 3, you ate carp. 1, that's great. Usually it's 0, okay? So we're talking about the bony fish, that you might think is the old boot you caught, off the bridge, and you threw it back in. I was in California once, and this was after coming back from Indonesia, where carps were just like, the #1 food source for the entire country. I was in California, and people were catching carps off of a bridge and throwing them on the freeway, where the cars were just sort of going back and forth with them. So, carps are among the most denigrated fish in the West. because they're non-indigenous and they're bony. But most of global aquaculture is in Asia, and most of world aquaculture is in Asia, and most of it's carps. Carps, okay? That's how when you really get, again, you know, think about global aquaculture. Of the 18 million metric tons coming out of Asia right now, 14 million is carps. Indeed, if you look at the top 20 aquaculture species in the world, according to the Food Agriculture Organization of the United Nations, look at the top 10 and you see 6 of them are carps. Okay? So remember, all aquaculture is in Asia, most of it's carps. Now you do see a few species in there that you might recognize. Oysters, tilapia, wow, tilapia has come up like a... You know, when I started in tilapia, I started in a farm in Southern California, you know, just outside in the desert of Southern California as my postdoc. And it was crazy because all of the home of all the tilapias in the world is Africa. And so the genetic home is Africa, and we imported them, the seed stock. But I remember, like, the first time we got a crop, we had to print a brochure for the public, and it said, say, T-E-E dash la, L-A-A dash P-E-E dash A-A. Say tilapia. Now, you know what it is today, but that word, we tried to change that word. We tried to change it to cherry snapper because we could grow it in seawater, because the American or the Western consumer, oh, tilapia, right? We had to really create the entire market for that, and now it's millions of metric tons in the world. But again, it only happened since the 1970s. So indeed, donkey, mules, and horse agriculture in the United States is much more important than aquaculture in the United States. Really. Look at the USDA statistics. They're not much different. Here's the top 25 commodities in the United States, and you see horses and mules exceed quite an amount U.S. aquaculture production. Okay? So again, it's not the blue revolution, please. I'm going to keep on saying it. It's like, how can we work with our students, with policymakers, with very important people in Congress, et cetera, to educate them that aquaculture is very primitive and we need to spend money, and we have an ethical and moral desire to stop taking food out of the hands of people in developing countries and exporting it to the rich countries, because that's what we're doing. It's a major measure of food justice on the planet right now. Okay, so let me step back, because this is going to be great stories, and I could tell you the great stories about aquaculture, the stories of aquaculture. And these are the blue revolutions that have happened throughout human history. This is his story and her story. Now, I'm going to give you the archaeological sort of hypothesis that myself and my colleagues are working on. We have documented aquaculture revolutions throughout human histories in these countries, and we're working on Australia and British Columbia. The British Columbia one is just coming out like in spades. It's amazing what we're finding. But whenever the population density of seafood-eating peoples, and I just told you Americans are not seafood-eating peoples, nor are Africans, and there's a reason why. Whenever the population density of seafood-eating peoples, comma, exceeds their ability to derive their aquatic foods from the wild, comma, they develop aquaculture. Wow! Whenever we can't get our foods at that level of density from nature, we develop aquaculture. And so throughout human history, when these societies reached a certain level of population density, aquaculture arose. And it arose in such a way that almost I can take these slides from 4,000 years ago and teach Aquaculture 101 to my freshmen. It's that sophisticated. So here is among the most sophisticated of them all. This is an actual rendering of the tomb of Thebaid in the Valley of the Kings. It's a bas-relief in the Nile Delta, okay? And it shows a remarkable integrated agriculture, aquaculture farming system. Now, in China, you see some of their the language that's used. It's some of the characters merge. Aquaculture and agriculture, they call them. You could be either interpreted as partners in love, or it can be interpreted as agriculture and aquaculture as one system. And this is one system. So you can see here a tank, and it's got a central drain, and those are tilapia. And on top, to control water quality, is what today we call aquaponics, growing plants and fish together. And then the central drain drains, these hieroglyphs talk about that central drain takes all that warm, nutrient-rich water from the fish waste. It takes it out to whole fields of agriculture and papayas. An integrated aquaculture, agriculture, farming system, and it gets better. The hieroglyphs describe the gender relations, because today in aquaculture, you cannot talk about the development or sustainability of aquaculture without talking about natural ecology and social ecology and people, the human dimensions of it. That's 4,000 years ago. And then some of the more stunning ones that we found. These are the Chinampas systems that spread throughout Latin America all the way through the Amazon. And we've just been studying an area called the Beni region in Bolivia. And these systems basically take very poor soils. They put a huge irrigation canals, they dug by hand, and they grow fish and aquatic organisms, snails, etc., plants, all integrated system, aquatic system. And then the soil is incredibly poor in that area, right? So they take the warm, nutrient-rich muds that have been enriched by the perturbations in fecal materials and really great manure of all the aquatic species, and they heap it on top of this. They create these beautiful raised beds everywhere. And then they do three-story agriculture, what some people call permaculture today, right? They've been doing it for thousands of years in these Chinampas systems. Well, this is the most amazing thing that's happened in the last few years. It's caused huge controversies in our communities. This is actually trees. This is the Amazon. There's trees over this. We've taken the trees away. This is ground-penetrating radar. And it's raised a huge controversy in communities. Is the Amazon actually been deforested? And was it actually incredibly densely populated? In this area, we can say absolutely yes. Those are raised beds, canal systems, former Chinampa systems, now buried underneath the Amazon rainforest in that part of the world. And so, was the Amazon, maybe it's a human artifact. Some people are going to want to go that far. I don't know if I want to go that far. Okay. But there are areas of Latin America and South America that we know were densely populated with cities, and they actually had problems with some of their marine food sources, and so they developed this kind of agriculture. You know, everywhere we look. So that was only one snapshot. Some of the stuff that we've done in British Columbia recently is pretty cool. So we asked the question when we went to, this is China, and we said, is this what the future of aquaculture is going to be like? You know, this would probably not be acceptable in the state of Maine, you know, doing aquaculture from island to island and cutting off, you know, any other uses. So clearly it wasn't. I mean, we can't just export, you know, a intensive, you know, sort of invasive model like that. We need an alternative path. So again, we wrote the book, and one of the more impactful works that we've been working on for many years now, on a global as well as local scale, because we work from local to global. You know, back in the old days, we used to say, you know, think globally and work locally. Nah, that doesn't work anymore. You got to work globally and you got to work locally. So it's local to global. So here I may be in Maine, but I'm using iterations of Maine, and I'm bringing them to Iceland, or I'm bringing them to Chile, I'm bringing them around, and we're working with local communities everywhere. But it's ecology. So and I'm going to now sort of say ecology in front of everything, because these are the emerging fields you guys may know about. It's no longer just engineering. There's all adjectives. Maybe there's always been adjectives in front of engineering. But now it's like design, architecture. It's ecological design, ecological engineering, ecological management, and social ecology. So these are the kind of the emerging fields of aquaculture. Now, you will see in journals called ecological engineering, in ecological management, in all of these different fields, it's not just oftentimes called aquaculture, but we're using the aquaculture toolbox, the knowledge base of reproducing things, cultivating things in nurseries, and putting them back out into nature. That's almost restoration, right? So this field also branches now into conservation biology, ecology, conservation agriculture, believe it or not, using the toolboxes, the knowledge base. And in some cases, it produces food. In other cases, it restores marine and other aquatic ecosystems. Okay, so I'm not going to belabor this point, but it's a mindset global shift. It started with fisheries, the code of conduct for responsible fisheries. And what did that mean? Now it's gone to aquaculture, the ecosystem approach to aquaculture. And as you can see, it is fundamentally interdisciplinary, fundamentally. Some people say it's one of the first transdisciplinary fields because look at all of what we got to do. And so we have to have a community of scholars. Nobody can do all of this. And we have to train the next generation of students to not be stovepipe in this is capture fisheries, this is aquaculture, and never shall the twain meet, because that's not the future. They meet everywhere, all over the world. So back in the old days, this is what I could do. I could put mommy and daddy together and produce babies in a hatchery and produce seed. I could actually find out how to feed them, produce new feeds, and then we could develop markets and we'd make money. That was the old days. That's not the case anymore. The case is this. It's not about this aquaculture business success. It's about society's success. Us, you hear it in Maine all the time, the preservation of working waterfronts, the future of coastal societies. And you see, it's tied to everything. It's tied. You cannot talk about feeds for fed species today without talking about the impacts on capture fisheries and the impacts on marine ecosystems. You must be in that sort of interdisciplinary space. And if you come down here to markets, that's what you're talking about. How about infrastructure? It's been found that most of the jobs in aquaculture operations are not in production. They're actually in the value chain. And so if you don't localize that, you lose all of the opportunities for the rural development of aquaculture and for localization of the economy. Okay, so this is now scoped globally. And it's just so important to have global guidelines for the ecosystem approach to aquaculture. So we've worked with the FAO now to develop the ecosystem approach technical guidelines. And you can read them. I'm not going to read them to you. The various principles, and they're very high-reaching and they're international. Why is this important? Let me tell you a real example of why this is important. About 2 years ago, I was asked by the Mozambican government to come and evaluate a massive shrimp farming development in the Refugee Delta of Mozambique and Tanzania. And every one of these opportunities, it seems like time and time again, they promise jobs for the local people and food for the local people. And then invariably what's happening is most of the jobs are technical experts by foreigners, and the local people really don't even get the food that they're promising. So the Mozambican government now, I can walk to them and I can say, okay, I'm going to use the spectacles, the lenses of the ecosystem approach to FAO's technical guidelines of the ecosystem approach to aquaculture, and I will report to you, government, on whether this proposal meets those guidelines or not. And then finally, the Mozambican government can say, no, we're not going to do that development if it doesn't produce enough local benefits and doesn't damage our indigenous ecosystems. That's how important it is that deriving some of those benefits throughout the world for a different approach. Now, you can imagine this is not new. You know, we've learned from our fisheries people, we've learned from our agriculture people as the movement towards more sustainable agriculture has happened. So we're just the Johnny-come-latelys in a lot of ways. There's nothing really brilliant. We just kind of go out and ask for help because we need help big time. Okay, so more higher-arching words. The most important thing is I want you to focus on is strategy. It's a strategy. It's not just the end result. So it's not, what we want to do, it's how we're going to do it. Okay, everybody wants more food. Everybody wants more jobs and economic development. How are you going to do it? Okay, so the participation of the people of the place. So we've got guidelines now. So the area of focus, this area, this is what we're going to look like. Second of all is the people of the place. What is going on before anything is proposed? Okay, in other words, a whole baselining strategy. And that includes like massive amounts of going backwards as well as interviewing the people of the place. And it's not just foreigners or people not of the place. It's training the trainers. And that's what we're doing. We're training the trainers to have a procedure of how to engage and do community-based aquaculture. So these days, now the National Science Foundation, we get a fairly major National Science Foundation grant for the state of Maine. We didn't get it on aquaculture and fisheries. We got it on this. We got it on this procedure, on social ecological systems. So those of you that are in this space in your various institutions, this is an enormous new sort of priority by our country and by the world, is how do we do this? How do we involve the people of the place to work on social ecological systems? It's not easy. But we do know now people are publishing in amazing places like conservation biology. They're publishing social ecology. This is social ecology. What are the accoutrements of a successful participatory process? And you can sort of see some of the things there. You may think some of it is commonsensical, but I actually now have developed kind of metrics along this in order to judge whether it was or not. And I can tell you the human dimensions of the science are just as important on what we want to do on the science or what we want to do with the communities. And that's where the real success stories are evolving now, is that, can we actually conduct these in various places? Okay, so, we've been thinking through this because oftentimes, like those of you in agricultural universities, you have an agriculture experiment station. And agriculture experiment stations are the greatest ideas of your scientists. They say, oh, new genetic thing, this, that, and the other thing. They get the greatest ideas of scientists, which are really fun and good and excellent, but it's not enough these days. The ideas of scientists on agriculture or even aquaculture experiment stations are not enough. You have to have something else. You have to have, because farmers have a lot of knowledge. I come from Saco Bay, just only an hour and a half from here. And Saco Bay has a size as about half the size of Chesapeake Bay. Chesapeake Bay has thousands of publications, 10 to 20 institutes, and probably 200 scientists working on it over almost 100 years. Saco Bay has 5 publications, 3 to 5 publications. Who has most of the knowledge about Saco Bay in a place like rural Maine or in rural Africa? Is the people of the place, the people who fish, the people who own land, the people who recreate. So that's, how can I bring that into my science? So this is kind of some of what we've been talking about, that we can get actually publications out of this. We can, in academia, by involving stakeholders in farmer-led and scientist-led cooperations, both on station and off station. In other words, for Saco Bay, we use their fishing boats. We don't buy our own boats. We go out with all of them on their fishing boats. They come to our university and they're involved in our in-university experiments. And then we keep on, it should be an arrow going back up. We continue talking about improvement, adaptive management, how we can be better over time. But it's basically, there's a whole nother world here. And it's, how can we work together? Team Technologies, and those of you who follow Sigma Psi, the Scientific Research Society, you'll know that they've been publishing big papers about this called Team Science. Just recently, there was a big conference down at NIH, National Institutes of Health, in Bethesda. Brought everybody from NIH, and they talked about the science of team science. This is a huge opportunity for us, and aquaculture is embracing a lot of that. Okay, so let me tell you about some of the low-hanging fruit. This is one of the world's largest aquaculture forms of aquaculture today. Markets, again, started in Asia. I actually talked to somebody here in this audience who ate some of our main seaweed salad last night. So the seaweed economy is booming. It's not only for direct foods, it's because they are loaded with heart-friendly, healthy omega-3 stuff for you as food. They're also absolutely an amazing pharmaceutical, nutraceutical storehouse of things that we could only dream about, important for human health and wellness. So as soon as I went to human health and wellness, you should start thinking about, as an aquaculture institute or center, I should be dealing with medical schools, nutraceutical pharmacies, departments of pharmacies. We got to put this together, because there's a miracle going on here. And the Asians have known about this for about a century. Heart disease, obesity, other human health issues that we're dealing with here are very low in Asia. We're labeling seafood as for human health and wellness. We're labeling seaweeds. And so we also get this side of, like, you're not going to be chomping on a kelp, right off the beach. We've got, who's going to be working on this with us is the Culinary Institute of America, and some of the brilliant seafood chefs that are arising. We're going to develop a whole new range, not just dried, seaweed crunching out of a package. I mean, they're going to be developing all kinds of really cool seaweed products. So we've got a big farm in Casco Bay off of Portland. They produce a frozen seaweed spaghetti that I dare you to tell the difference between some of your best, sort of wheat and other type noodles. It's fantastic. You just bring it out of the freezer, you put it in, boil it up like as if you're doing that, and you're eating seaweeds. So the seaweed economy is booming everywhere. Now, why is this cool? Remember, it's not salmon. It's not fed. This is all the non-fed aquaculture. What does this do? It does bioremediation. It sucks up nutrients. It also dampens waves from beach erosion, okay? And for kelps, you grow it in the winter. We lobster in the summer. So lobstering out there is a big deal, right? They take up a lot of the ocean. There's user conflicts. They have zones. There's conflicts. But if they can be involved in seaweed farming in the winter when they're not lobstering, beautiful. A livelihood solution potentially for the future of lobstering is going to be doing off-season, on-the-water enterprises. But we got to know that. If I hadn't been dealing with the lobster industry, how am I supposed to know that the traps all start to move out, in October in Saco Bay? Okay, and then how about this? This is the largest food source on the planet. It's detritus. It's detritus. It's unconsolidated organic matter. It's almost like compost, but it's better. So compost has a lot of bacteria in it. When these particles come down from the land, and they're land-based particles we know as terrigenous or terrestrial material, it gets colonized by bacteria, by fungi, by algae. And a protein concentration of this particle goes whoop, and it could be almost 70% protein. This particle, the ocean is a magic transformer. And so who eats this stuff? Everything. Everything eats this stuff. Shellfish, we're finding out, shellfish are not aquatic cows. 100 years into growing shellfish, we've only found out that they don't need to eat the grass of the sea, phytoplankton, that they eat a lot of this. And so we've been neglecting detritus as maybe, okay, where are the detrital flows? Maybe that's the best place for the shellfish farms. My goodness, we've been growing this animal for 100 years and we didn't know what it ate? So again, the evolution of the blue revolution. Okay, so we've been working on these things. Since we found this out, the cool thing is that, again, we don't need to be at the water surface. Okay, we're not gonna, you can still fish over us, you can still lobster, you can do everything. And we could be in deep water because there's a huge amount of detritus in deep water. Now we need to get the engineers together with us. We need to be smart engineering to not entangle whales and to find innovative ways of snap-off gear, etc. The cool thing about it is some of our colleagues from the University of New Hampshire did implement mussel farming in deep waters off the Isles of Shoals, just about an hour and a half south of here. And they found that the mussels grew so fast with big giant meats that you would never recognize as mussel meats that the calcium metabolism in the shells couldn't keep up with the meat metabolism, and the shells were fragile. So they couldn't pack them in bags like they normally do with mussels because all the shells would crack. So they had to develop a different type of packaging, almost like an egg carton with individual mussels all the way through. And then they didn't want to sell them anymore because as soon as they started to sell them, the consumer said, that's it, I don't want any other mussels. I will not take any of your mussels, I only want these. I just want these mussels. So we're in the beginning stages of developing deep water, offshore farming systems that require no food. Okay? We don't have to feed these. The world feeds these. And so there's a huge amount of detritus out there. Okay, I'm going to start wrapping up here, but the other one is let's go a little bit on shellfish. We think we have now a global consensus that shellfish aquaculture needs to be expanded, that it's more socially and environmentally acceptable to the public. So we're working on this, and you can see, I'm not going to go into this in depth, but we have a National Academy study on ecosystem concepts for aquaculture. We have technological advances, and we know we can do it where the coast is crowded. We know we can work out the user conflicts. So I'm going to start to end a little bit on thinking really outside the box now, go away for a bit from food, that this is a toolbox of skills. And we can use the aquaculture toolbox for restoration of damaged marine ecosystems and for conservation. So we do this with our national forests. You guys I have no problem with this. You look at that and you say, wow, replanting trees in our national forest, that's cool. No problem there, right? No problem with you thinking about silviculture or tree agriculture and tree hatcheries and tree nurseries and planting trees. You have no problem with that one, okay? So we're doing the same thing, okay? With using the aquaculture toolbox, we'll call it marine agronomy, okay? But we're now actually using the aquaculture brain, okay, to go out and get seeds from salt marsh grass, put them in nurseries, and plant salt marsh grasses to help restore salt marshes. We're doing this big time with mangroves. We have mangrove nurseries, and we're putting out mangroves. And then you probably are not aware, but aquaculture of corals is a big deal. We can, what we call frag, we can reproduce corals, endangered corals, any corals you can do. And we can put them in, again, we can reproduce them in hatcheries, we can put them in nurseries, and we put them out in vast coral gardens in the tropics. And we can restore coral reefs. And we're using, this is all aquaculture. We're using the toolbox to restore nature, not just produce food. But then, as soon as we start restoring coral reefs, who comes back? A lot of the nearshore fisheries. Okay, so this is just a recent article. I think I just took this one out just to show you. So people are using now, eelgrass, which is really, really sensitive and very important. They're making eelgrass machines. They're doing eelgrass seeding all over the place. And then way out there. So what is the future of offshore, now outside of the 3-mile zone, where it's really crowded when you get futuristic things? So we're not doing any of this in the United States, but other countries are already, particularly Germany, is way ahead of us. And what they're thinking of is because Germany, again, as you probably know, after Fukushima, had a strong national policy to move away from nuclear energy. And so they're moving seriously into renewable energy. And that means renewable energy not only onshore, but massive offshore. And let me just show you what some of these systems that they're putting into place. So these are the monopile towers that they have, wind power offshore. And they're thinking if we're offshore, we're going to do integrated food and energy systems. So they're talking about deep water, shellfish, and seaweed systems in the offshore integrated with wind power systems, which is, again, all going to be going into the European market, not only using the towers, but also using the area, deep water areas between the towers, the lease areas, to put new food systems in. Okay. So maybe just end on something to think about. If you're thinking about increasing your diet to what the government says is recommended, you eat seafood 3 times a week, and then you're really, really worried about contaminants, well, there's a whole group of scientists that have been working on contaminants in seafood. And what we can say is that now we have various cards for you to make choices. Well, one of the cards that we were working on is what happens if you don't eat seafood. Okay, if you don't eat seafood, and what is the real risk to you as a young child, as a young woman of childbearing age, or an older guy? And so there's really different messages. They're refined now, and one of the things that we've been working on intensely is this whole controversy about mercury. And so you're going to start to see a lot more sophisticated information coming out to you about the health benefits of eating seafood versus the risk from contaminants. So one of our colleagues at the Harvard School of Public Health has said that it's a human health crisis in the United States, that people are not eating enough seafood, they've been scared away from seafood because of some of the contaminant issues that are really non-scientific. Okay, so if you care about these great places, what I encourage you to do is to birth within your institutes a little bit more broader thinking about the nature and the opportunities of food from the ocean in the world today. And thank you very much for your opportunity.
So we have plenty of time for questions, and I've got a whole list. I'll let you guys.